Okay, hello everyone. Let me just making sure, setting up my environment in. Okay. So, hello everyone. My name is Jeesun. I'm a senior UI developer on Vibrant team. For those who don't know what Vibrant is, it's a mobile wallet that makes it easy for Argentines to get paid and save in USDC instead of pesos that's been facing crazy inflation. But today, I'm not going to talk about UI development or Vibrant. I'm going to talk about writing smart contract on Soroban, and I wanted my first smart contract to be about creating NFT. So I was thinking about what NFT use case that I particularly like in the past, and one I really liked was Coachella ticket NFT. So I decided to apply that concept to Taylor Swift's Eras Tour concert. And I decided to use Taylor Swift Eras Tour as an example because A, I really want to go, but B, as we all know, she recently had some trouble with Ticketmaster where they kind of control all of her concert logistic, like ticketing and upsetting fans. So I was thinking, wouldn't it be nice if artists kind of have control over their concert tokens, and let's say Taylor Swift does issue her concert tickets on Soroban, then like Vibrant, for example, maybe can handle some of that tickets in Argentina. Decaf can do some of that in Mexico, or Beans can handle that logistics in Europe. And meanwhile, she can still have that control over her tokens. So I am also going to walk through this map. So if you ever use Ticketmaster, you're kind of familiar with these concepts of like picking seats. And yeah, so this NFT grants exclusive privileges, including priority access to future ticket releases. I thought this was very important because, let's say Taylor Swift issue all of her concerts. She's had 5 concerts so far. Let's say she issue all of her concerts from the beginning on blockchain, then she will be able to tell which fan has been there for her since the beginning. And that would give her some opportunity to kind of token gated. It's like, you've been there for me since the beginning, so you get to purchase these tickets first before anybody else. Second privilege would be discounts on upcoming ticket purchases. And the third is the opportunity to connect with fellow Swiftie within your designated seat group before the tour. So in this example, what makes this ticket unique is your seat number. So let's say I bought this seat number 1, I get my NFT saying seat number 1, and if we group these 1, 2, 5, 6, 9, 10, 13, 14 as like some kind of group, and I know it's possible on Discord where you can create a channel. It's like, hey, you guys have this NFT, interact with each other before the concert, and that would be kind of cool way to, even like solo concert goer, they can meet up with each other before and go to concert together and have fun. So that's the idea. I'm not gonna implement all of that. I'm going to keep this contract very simple. So let's talk through what functions we are going to write. The first function we're going to write is mint. And if we look at ERC 721, we're going to adopt 2 of ERC 721 interface. The first one would be transfer, and we will also implement owner of. So yeah, let's create this, and I am going to walk through. Let me do this actually. I'm a little nervous. Enough. Oh, never mind. So let's go through setup doc. I've already installed Rust. I've already installed Target. I already configured my editor. I've already installed Soroban CLI, and we can tell that by typing in Soroban. And we see that I have the same exact output as the doc says. I will go through Soroban auto-completion later when we deploy our contract. But let's start with hello world. So I am going to create a new Soroban project, and I'll name it Store NFT demo. And I will go to Store NFT demo. I will open my visual code. And yes, I trust the authors. And I will copy and paste this cargo toml here. And I am going to import a cheat sheet in case, I'm about to forget how to speak English. So just in case I forget how to write Rust, I'm gonna import this cheat sheet, but I'm not gonna use it right away. I'm gonna kind of test myself if I can do this, and I think I can do it. So we'll start with writing smart contract. So the first thing we need to do on Soroban is to declare that we are not going to use, I think this is right. Right? Okay, yeah. Not to use Rust default standard library. We want to keep our contract as small as possible. The max size is about 64 kilobytes, so we do not want to import this big standard library to our contract. And the next thing we're going to talk about is storage types. I am not going to go through in depth on how it works, because Garen's going to talk about it at 120 here. So let's talk about how we are going to store our contract. So let's do storage types, and I believe it's like derive clone, and I think it's contract type. A nice thing about this is like it auto imports contract type for me, and I'm going to write this data key, and this will be our shared state that we'll be using throughout our contract. And usually when we say shared state, we usually use instance. And in this, we are going to save name of our contract, symbol of our contract, and admin of our contract. So we'll do name, symbol, and admin. And next, we are going to save our user data. So that we'll be using persistent storage, specific to user. And I'm going to save token owner, seed number, because that's what makes our contract unique. And you'll be pop enum user data key, and you'll be token owner, which takes unsigned integer, 32-bit integer, and is going to take seed number, and this will return a token owner in address form. And the next would be seed number, which takes address. So take scene address and return a seed number. So we have our data set here. I'm going to copy and paste and bring it over here, so I don't want to scroll up and down. So that's what we're going to do, and we will start with contract. And I think it's pop construct. Was it pop? What was it? Pop? Was it pop construct? Obstruct, yeah. So obstruct, era store NFT contract, and I will do contract implement. And its function was implement era store NFT contract. And we can start writing functions. So, it's throwing error. So Soroban is really nice. It like throws an error for you, and it asks you to fix it. So I fixed it here by importing it. And within our contract implementation, Soroban contract always has to start with initialize. So we're going to start with initialize, and we talked about creating min function, and then we talked about checking owner of, and then transfer. So we will start writing initialize. And initialize, all Soroban functions takes like Soroban environment. So it always starts with environment. We will start with name, string, symbol, and we also need to check the admin of the contract. So admin address. And the first thing we need to do is making sure that this contract does not have admin. And we see Soroban is throwing an error because I didn't import this. So I'll import this. And we check this by checking our storage. So if our storage, we talked about using instance. So instance has data key admin, then you throw an error, and it should be double colon. So if you panic, this contract already has an admin. And if it does not have admin, then we are going to start storing name, symbol, and admin. So let's store name, which is environment storage instance set data key name is name. I always forget to use reference, so I like that it's letting me know. And symbol is symbol. And admin, what's wrong? Oh, reference. And admin, and admin. So our initialize is done. Next, we'll talk about minting. And just like initialize, it takes in environment, it takes in address that we're going to send it to, and seed number, which is U32. And we want to check and see if the address that we're going to send it to has no seed number assigned. So we can do that by instance has user data key. I'm just going to copy and paste. User data key, token owner, seed num. If this user has the seed number, we are going to panic and says, this receiver already has a ticket. But if not, we can start saving it. Oh, and it should not be instance, it should be persistent because it's user data. Persistent, set user data key, token owner, seed num is 2. And is this wrong? Our next token address. Oh, seed 2. And for seed, that will take to clone, and this would be seed number. And I have to reference this. Or what did I make a mistake? Oh, I keep doing this. Extra parentheses. And we'll just keep going. We'll do until owner of so that we can kind of create tests and check everything we've done so far. And let's do owner of. Does the same thing. You take some environment, seed number, 32, and let owner, environment, storage, persistent, get, user data key, token owner, seed number. Oh, is that right? And then we will return this. What did I do wrong? Oh, unwrap. We have to unwrap gap. And things I learned while writing Rust on Soroban is that when you return something, you don't put semicolon. I thought that was interesting. Yeah, so let's test what we have done so far. I'm just checking my time. And for our test, I'm going to use my cheat sheet. It's my cheat sheet, and I'll walk you through what this test is talking about. So earlier I said, do not bring in Rust standard library because it will create file size too big. But here we have this configuration attribute, which allows you to run this code only when you run certain conditions. So here, I forgot to run terminal, but in this case, it's like if you do cargo test, run this code. When you run cargo test, you should go through this file. So I'm going through my cargo test here. And you should probably throw some error because I have all these unused stuff. And unused variable. Oh, see, it's like Soroban's very nice. It tells me where I made mistakes. So here I made a mistake. I put symbol, but it should be admin. And let's write our first test. I think it was test and function mint or owner of. And it always starts with environment. And it should be environment default. And we start with, so I'm noticing that it's not like, usually it cannot show me the preview of what I'm about to write. And that is because I forgot to do mod test here. So once I do mod test, it shows me all the error that I made previously. So now it's linked to my smart contract, and we can kind of, we can start writing it. And this is mismatch types, reference, address. I am not, oh, okay, this is name. Okay, because I have my arguments switched. So, what is this? So my first thing is a string. So it's the era store. Symbol and admin goes at the end. So yeah, now it's not screaming at me, which is great. And we will create, oh, let's create admin first, which is, I believe, address random environment. I did this so much, so I kind of remember things. And then let's create Swifty fan. So Swifty number 1, and we will create Swifty number 2, and we will create our token, which is create token environment admin. And now we can kind of test our function. So let's try minting. So let's say we want to mint it to Swifty fan number 1, and we want to mint her seed number 1. Then we can bring this assertion, and this should return true, because I'm checking to see, hey, who owns seed number 1? And you should say, oh, it's Swifty fan number 1 that owns that seed. And it's throwing me error because, why? Swifty fan. Actually, I'm just going to run the test and see why it's doing that to me. Swifty. Owner of. Okay, let me just go cheat. Is it because mint, there's token mint 2? Why is that not working? Oh, wait, I do. Oh, right, address. Thank you. See, you guys are so helpful. Oh, live coding, Okay, what else? Okay, I'm gonna clean this up. Let's try to send it to Swiftie number 2. We're gonna assign her seed number 2 to Swiftie number 2. And we will change it to 2 and 2. And we run this. And we pass the test. And I kind of wanted to also highlight, because I'm a web developer, so I'm so used to like console.log everything. So when I first started this, I'm like, how do people know how to use this thing? But there's a thing like macro called log. And this allows you to log the value that you want to check. So here I'm going to say, okay, there's min function, and I want to check the seed number that we are calling. And we're going to have the seed number here. And we can also, okay, let's do seed number. Let's keep it simple. Why bother? And in test, I told you about we did this testing. Here we're importing raw standard library because what we're about to do here is to use this built-in logging function from Rust library. So it's this print next line, and if we run this here, it should log what I added in my contract. And you have to use this no capture. So not just cargo test, but with no capture, and it shows you my log. So scene number 1, scene number 2. And checking my time, I have 8 minutes. So I'm going to just copy and paste this transfer function, because we don't have time to write this from the beginning, but it's very similar to our min function that we did earlier. And we will just add one more test on transfer. And we did mint. So Swiftie number 1 has this token, and we're gonna create Swiftie fan number 3. And Swiftie fan number 1 is going to transfer the token to Swiftie fan number 3. And we can check this. You are screaming. Oh, it's from to, oh, scene number, right, which is 1. And owner of number 1 now should be Swiftie fan number 3. And we will do cargo test. And wait, hold on, let's do cargo test. I don't want testing. Oh, my bad. I didn't add this test for transfer, so it's not running it. But yeah, now we see we have transfer, passing, bin owner of passing. So now we are going to build and deploy our smart contract. Just checking my time again. Let's do, actually, let me show you the bash auto-completion that I mentioned earlier. So let's do this. We did storing data earlier. We did deploy to testnet. Actually, no. Okay, so we have this auto-completion for Soroban CLI. So if I show you right now, if I do Soroban here and click tab, nothing really happens. It just shows me what's happening, what is in my current file. But once I install this bash auto-completion to my CLI, now I have all these commands display telling me what I can do with Soroban command line. So we can now easily do deploy testnet. So config, network, no, add global testnet. Actually, I'm just going to copy and paste this. Let me just do this. Yeah, at the network, we're adding testnet network, which went live last week. And we will add our identity, generate global, which is admin. And we can do Soroban, config, identity, address, admin. And we will fund our admin. And my Docker is running, so this should be working fine. And yeah, my admin got funded. Oops. And I think I forgot to build my contract. So let me check if yes, I didn't build my contract. So let's quickly build my contract. So I will get that WASM file that I need. So it's right there, it's building. We'll wait. Yeah. How's it going, guys? So it's running. All right, we have our WASM file ready to deploy. So I'm going to clean this up and contract, deploy, and WASM, target, WASM, unknown, release, WASM, and source is admin, and network is testnet. And we'll wait, and you would give me a contract address. It better give me contract address. And I'm going to create a Soroban folder to save this contract address, and I will do echo and Soroban hello ID. Is it hello ID? Oh yeah, hello ID. And our contract is now saved here. And yeah, we just deploy our contract on testnet. And this is the end of my talk. But if you're interested about how to hook your front end or web app to your Soroban contract, I encourage you to check out Chad and Julian's talk at 2:20. I have three minutes left, and I just want to say that I'm a web developer. I never used Rust before, and building on Soroban was really good way to learn a little bit of Rust. So if you're interested in learning Rust, I highly recommend going through Soroban doc and experiment with it. And yeah, thank you for paying attention to my talk. Thank you.
That was awesome. Thanks, G. That was